Hey, welcome to lesson 1.4, and we're going to talk about SI, or System International Mass, and in this lesson we'll talk about how is mass measured, and what are the common units for measuring mass in the SI system, and how to convert one unit of mass to another unit. So first things first, we need to get a misconception out of the way. In our day-to-day lives, we use the words mass and weight as if they're the same thing, but they are not. All right, so weight is the amount of force due to gravity on an object. All right, the amount of force. All right, now this changes depending on what planet you're on. All right, so this changes on different planets. All right, pardon my penmanship there. I'll try to get it better. Now, mass, however, mass is the amount of matter in an object. All right, so this is how much stuff something is made up of. All right, so the amount of matter. All right, so that doesn't change. All right, my mass doesn't change unless I physically lose matter. Okay, my mass would change if I lost an arm because there would be less of me. Okay, but that doesn't change depending on what planet I'm on. Okay, so mass stays the same. Alrighty. Now that being said, now that you know the difference between mass and weight, the rest of the world still kind of doesn't. All right. So in everyday conversation, people use the terms weight and mass interchangeably. They are related, but they have different meanings. So your weight depends on gravity, and your mass depends on the amount of matter. But look at this. Even on our driver's license, they're saying our weight is 52 kilograms. And kilograms is a unit for mass, not weight. All right, so even though we know they're different, we have to understand when people say weight, they often mean to say mass. All right, so in the SI system, or the metric system, the base unit for mass is the kilogram. Now, originally, the kilogram was defined as the mass of 1 liter of ice water. Okay. Well, that's kind of how the SI system works. They like their stuff to be related. So now mass, kilograms, is related to volume or capacity because it's related to liters. Now, a few years later, they changed it just a little bit. They changed it so it wasn't 1 liter of ice water. They said, okay, 1 kilogram is now going to be 1 liter of 4 degrees Celsius water. And I know what you're thinking, like, well, that's such a little change. Now, the reason why they changed it is because at 4 degrees, water is at its most dense. All right, so, and then eventually they changed it again, and then the definition now stands as 1 kilogram is the weight of that cylinder. That little cylinder there. Now, that cylinder is tucked away somewhere in a safe so that it cannot change due to corrosion or anything like that. So that is the definition of what 1 kilogram is. Now it's changed very, very little. It's still very close to about the mass of 1 liter of water. All right, let's do some examples. So Marty weighed himself on a bathroom scale. He weighed 61 kilograms. Later that day, at the store where he works, he lifted 5 dozen 1 liter bottles into the trunk of a customer's car. He told the customer that He just lifted his own weight in water. Was Marty correct, or was he lying? All right. So first, let's figure out how many liters of water he lifted. Okay, so he said that he lifted 5 dozen 1-liter bottles. All right. So dozen means 12. So 12 in a dozen, and he lifted 5 dozen. 12 times 5, that means he lifted 60 bottles. Spelling is difficult. Alright, so that means that he lifted, well, because each bottle was 1 liter, that means he lifted 60 liters. Alright, now, looking back on our previous slide, we said, well, 1 liter of water is about the same as a kilogram. So 60 liters, that's about the same as 60 kilograms. So he lifted 60 kilograms just in water. So, I don't know, I guess he was pretty close. So he lifted 60 kilograms of water. So, I don't know, maybe with the mass of the packaging, so the bottles themselves, and maybe they're in a box or something like that, then yeah, maybe he was probably pretty close. Okay, so yeah, he lifted pretty much his weight. So yeah, he pretty much did. Giant exclamation mark. Pow. Nice. Alright, so we said earlier that the SI system, or the metric system, likes the units to be interrelated. Alright, so we said earlier that 1 kilogram is equal to 1 liter of water, or the mass of 1 liter of water. Of 1 liter. Now, that is of water. Alright, if you're talking some sort of other liquid, it won't be exactly the same. Now, the prefix kilo means 1,000. Alright, we talked about that earlier. So that means kilogram means 1,000 grams. So 1,000 grams equals 1 kilogram. Now remember, 1 liter of water has a mass of 1 kilogram. But 1 liter is the same as 1,000 milliliters. And 1 kilogram is the same as 1,000 grams. So, based off that, we can say that 1 gram is the same thing as 1 liter, not 1 liter, 1 milliliter. 1 milliliter of water. Now, that's comparing capacity and mass. Now let's bring volume into it. Now, if we can think back to one of my previous lessons, 1 milliliter is the same thing as 1 cubic centimeter of water. Right? So if you had a nice little cube of water, like an ice cube, a little baby one. Right? So now we have volume, capacity, and mass all related through water. So 1 gram, which is mass, is the same thing as 1 milliliter of water, which is the same thing as 1 centimeter cubed of water. Which is really cool, because now we can relate these different units. Alright, let's do one more example. So, a dime has a mass of 1.75 grams. I want to change this into kilograms, and then I want to find out how many dimes there are in 1 kilogram. Alright, so first, let's change this into kilograms. So I'm going to set up here a handy-dandy skeleton equation. Why? Because I love them. Skeleton equations are my favorite. All right, so if you remember, the first number is the number from our question. So that's from our question, which is 1.75 grams. And I'm trying to change it into kilograms. Now, this number here comes from our formula sheet. So we'll look up and be like, hey, look at that. 1 kilogram is the same thing as 1,000 grams. So this number here is going to be 1,000. And this here is going to be multiply or divide. So we're switching to a bigger unit because a kilogram is bigger. So our number needs to get smaller. So we're going to divide. And when we do our division, we can just move the decimal 3 spots to make the number smaller. So I'm going to move the decimal 1, 2, 3 spots. So now my decimal is here. I've got 0.00175 kilograms. Very, very small mass. So I want to figure out how many of these things are in a kilogram. So what I'm going to do for part B, well, I know 1 kilogram is 1,000 grams, but I also know that 1 dime is this 0.0075 kilograms. So to figure out, I'm going to divide it by the mass of a dime, 0.00175. All right, so that's how many kilograms are in a dime. All right, so that one I can't really do in my head. So I'm going to do 1 divided by 0.00175. There's my answer, 571-ish. So it's 571 dimes. Awesome. So 571 dimes is the same as 1 kilogram, if you can picture that as a referent. All right, so I guess for my next video, we'll talk about larger masses. Thanks.